Join us as we tackle coding challenges on Code Crusaders. In this video, we'll be diving deep into the problem by addressing 5 crucial elements: the problem definition, our approach to the code, an example to illustrate the code, the intuition behind the code, and the complexity analysis. The problem is, restore IP addresses. The problem statement is asking to restore valid IP addresses from a given string. An IP address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. It consists of 4 integers separated by single dots, where each integer is between 0 and 255, inclusive, and cannot have leading zeros. Given a string S containing only digits, the task is to return all possible valid IP addresses that can be formed by inserting dots into S. You are not allowed to reorder or remove any digits in S. You may return the valid IP addresses in any order. Now coming to the approach used in the code to solve this problem. Initialize an empty vector to store the valid IP addresses and a variable to store the length of the input string. Use 3 nested loops to generate all possible combinations of the input string by inserting dots at different positions. In each iteration of the loops, divide the input string into 4 segments and assign them to the variables segment 1, segment 2, segment 3, and segment 4. Check if all the segments are valid by calling the isValid function, which checks if the segment has leading zeros, is greater than 255, or empty. If all the segments are valid, concatenate the segments with dots in between and add it to the vector of valid IP addresses. Return the vector of valid IP addresses. In helper function isValid, check if the segment has leading zeros, is greater than 255, or empty. Return true if all the above conditions are false. The intuition behind the approach used in the code is: to find all possible valid IP addresses, we need to insert dots in the input string in different positions to form different combinations. We can use 3 nested loops to iterate through all possible combinations of the input string by inserting dots at different positions. In each iteration, divide the input string into 4 segments and check if all segments are valid by calling the isValid function. A valid IP address segment is a string that is between 1 and 3 characters long, does not have leading zeros, and is less than or equal to 255. If all segments are valid, concatenate the segments with dots in between and add it to the vector of valid IP addresses. We are using backtracking and unordered set to check if the subarray is already present or not. If yes, then we will not add it again in result. Using hash function, we are creating unique hash value for each combination so as to check if it is already present or not. Using unordered set, we are reducing time to check if the subarray is already present or not. Using backtracking, we are traversing through the all possible valid IP addresses. Let's take an example to understand the code better. Example: input S equals 25525511135. Initialize an empty vector validips to store the valid IP addresses, an unordered underscore set hash values to store the hash values of the combinations, and a variable input string length to store the length of the input string. We use 3 nested loops to generate all possible combinations of the input string by inserting dots at different positions. In the first iteration, the loop variables will be first dot equals 1, second dot equals 2, third dot equals 3, which means that we are inserting dots after the first, second, and third characters in the input string. Now, we divide the input string into 4 segments by using the loop variables as the positions to split the string. We assign the segments to the variables segment 1 equals 255, segment 2 equals 255, segment 3 equals 11, segment 4 equals 135. Next, we check if all the segments are valid by calling the isValid function. The isValid function checks if the segment has leading zeros, is greater than 255, or empty. In this case, all the segments are valid. We concatenate the segments with dots in between and add it to the vector of valid IP addresses. Using a hash function, we are creating a unique hash value for the current combination and checking if it is already present in the hash value set or not. If the hash value is not present in the set, we insert it in the set and add the current combination in the validips vector. Similarly, we repeat the process for the remaining iterations and get the valid IP addresses 255.255.11.135, 255.255.111.35. Return the vector of valid IP addresses. In this way, the updated code uses backtracking, unordered set, and hash functions to check for the duplicates and find all the valid IP addresses efficiently. The time complexity of this solution is big O1 because the number of iterations is fixed, regardless of the size of the input string. The nested loops iterate through all possible combinations of the input string by inserting dots at different positions, which is a fixed number of iterations. The function isValid also has a time complexity of big O1 as it checks the length of the segment, whether it has leading zeros, and if it is greater than 255. The space complexity of this solution is big O(n), where n is the length of the input string. This is because we are using a vector to store all the valid IP addresses, and the maximum number of valid IP addresses that can be formed is equal to the length of the input string. Additionally, we also use a variable to store the length of the input string and a variable to check if the segments are valid or not, which also contribute to the space complexity. Thanks for following along. I appreciate your attention, and I hope you found this explanation helpful. If you found this video helpful, make sure to hit the like button, leave a comment, and subscribe for more content like this.